mode.
Hello everybody and welcome to our latest webinar series called The Way We Work webinar series. And over the course of the next few days we're going to be looking at a number of webinars that will explore current and future trends in testing. And we're going to begin the series with a webinar on programming for testers with Graham Thomas and Philip Isles. We'll then have a webinar on DevOps with Rob Lambert and his team at New Voice Media. Then Adam Knight is going to have a session on big data, and Professor Andy Stanford Clark will wrap up the series with a presentation on the Internet of Things. So today's webinar is Programming for Testers, It's Easy, and it'll be presented by Graham Thomas and Philip Isles. If you have any questions for Graham or Phil about the content of this webinar, just type them into the questions field there on the control panel. And at the end of the webinar, then we'll have a look at your questions. And we'll pose those questions then to our two presenters. We also have a competition running this week where at the end of this webinar, I'm going to share with you guys a number. And I'm going to be sharing a number with you during each of our webinars this week. So all you'll need to do is add up the 4 different numbers and you email them to me on Friday. So I'll share the email address with you on Friday's webinar. So now I'm going to hand you over to our presenters, Graham and Phil. Hello, guys.
Hi, Dara. Thank you.
Hi, Dara.
We're just going to open up their screen here and we'll get underway.
Is that the right screen, Dara?
That's correct now. We can see it.
Okay. Welcome to everyone who's dialed in for this webinar, Programming for Testers, It's Easy. I'm Graham Thomas, and today I'll be co-presenting with my good friend, Phil Isles.
Thanks, Graham. Hi, I'm Phil. I work as a test manager for a large international bank, but I'm not a licensed spokesperson for the bank, so I can't tell you who I work for.
Phil and I will be co-presenting today. We're in different locations, so that might be a small challenge for us because we can't see each other. Good luck with that. I think this is the first time someone's attempted this on a webinar. Okay, slide 2, the abstract. So as we said in the abstract, we hear a lot about these days about testers should learn to code, become more technical and have more development-oriented skills. Unless you came into software testing as a burnt-out developer, it's unlikely that you have coding skills or a deep understanding of the technical ins and outs of your current systems landscape. What can you do about it? Is programming hard? How can you learn to code, gain the benefits, and still master your current workload, which keeps on relentlessly increasing? In this webinar, which is a companion piece to our EuroSTAR 2014 Advanced Workshop, we show you how easy it is, actually is, as a tester to learn how to program. The hard part, as always, is how to start. So we will start with 3 simple steps and show you how to get up and running with Python. And to help you back in the office, we'll arm you with some of what we think is the most useful online references and information that's available. So each journey starts with a single step. Let us help you take your first programming step today.
So the key takeaways that hopefully you'll pick up on today are a deeper insight into the testers need to learn to code debate, also your first steps into programming, and the experience, examples and references that we'll give you towards the end of the webinar to help you continue your programming adventure. So now we've got a poll just to get an indication of who has what programming skills.
We've just launched the first poll there now.
Yep.
What level of programming experience do you have? So if you can just tick the relevant box for you. We'll just leave the poll running for a little bit. We are up to 65% have taken part in the poll. We'll run a little bit longer now here, up to 75. So if you haven't already taken part in the poll, please do. We'll give it another 15 or so seconds. Okay, I think that's everyone really there who's going to take part in this poll. So I'm just going to close it now, and I'm going to share with you the results. And there you guys have it. Can you see that there, Graham and Phil?
I can't see it, Dara.
Oh,
Phil,
I can. We've got 25% of no programming experience, 67% with modest experience, and 7% who are experienced. So thank you for taking part in that poll there.
Okay, let me just hide that poll and we'll go back to the slides again now.
Okay, are we back?
Yeah.
We are back. Slide 3. Yep.
Okay, so the agenda for today. Our journey is to firstly tell you a bit about, our agenda for today is firstly to tell you a bit about the journey that Phil and I went on to deliver this workshop. Then we'll move on to talk about the why learn to program. We'll look at the benefits you can gain from learning to code. And I'm using the terms programming and code interchangeably here, so please don't be confused. Coding is the act of writing code. Programming is the name it had in the past for writing complete programs. We'll then move on to talk about the how to code, where we'll relate the workshop exercises to you. Obviously this isn't an interactive workshop, but we'll try and give you a flavour of that. We'll give you an insight into why programming is so much more than what we actually cover today. Is it really easy? We'll try and answer that question. Finally, hope to encourage, inspire and motivate you to take on your own programming journey.
Over the last couple of years, I'll say I've really enjoyed my journey. I've got to meet lots of new people and I've helped them with the beginning of their own journey into programming. I started out programming several years ago, then moved into a formal testing role, and now I'm actually looking again at how a better understanding of code can help me as a tester.
And the picture of Pluto here, it's a bit of an analogy to the journey about learning to program. On the left is a picture of Pluto taken by the Hubble telescope, and until February this year it was the best view that we had, a bit like how programming and program code may appear to non-coding testers a bit fuzzy and blurry. The picture on the right is one of the high-resolution images of Pluto taken by the New Horizons probe as it passed by in July this year. We can now see the detail, the colour, and already we have a much better understanding. It's a great photo and it's available on the NASA and the New Horizons website. Okay, on to slide 4, which is our journey. As Phil said, our journey began 2 years ago. Phil and I were at a UK Testers Retreat meeting in the north of Netherlands. We were asked by one of the attendees if we'd like to submit for a conference. We said yes, but what we'd really like to do is run a workshop showing testers how to program or code and use free tools, only use free tools, show testers the basics and enthuse and inspire them to want to learn more.
Our submission was later accepted for Belgium Testing Days, the conference there, and we chose to use Python, the Raspberry Pi, and to make it a bit of fun, a USB-controlled robotic arm. Before the conference, Graham and myself sort of rehearsed a workshop with some colleagues where I work. We learned a lot about the mechanics and that it was actually achievable to run a programming workshop in a couple of hours. One of my colleagues actually undertook the exercises running a Python environment on his Android phone. We don't recommend this for beginners.
Yeah, we were subsequently asked to do the workshop at 6 conferences in 2014, including EuroSTAR, where we had over 100 delegates. And this made us realise that there really is a demand from within the tester community to learn about testing. And amazingly, at every workshop, a tester who had previously not written any code before, a non-programming tester, successfully completed the final exercise, which was a challenge to program a USB robotic arm.
At the time, we were both learning Python on the Raspberry Pi, as it was cheap and fun, And we're also getting friends and colleagues interested in doing it as well.
So we had 3 months to design and deliver a workshop, so we had to get going. As we said, we decided to base the workshop around Linux and Python. We wanted to show how easy it was to get started, so we chose the Raspberry Pi, as you can see on the top right there, a credit card sized computer, fully functioning Linux computer, which costs only $35. Linux is a free open source operating system. The Raspberry Pi 2 is a quad-core gigahertz processor, and it's, as I would like to say, IoT ready, so Internet of Things ready.
We decided to use Python as the programming language. Again, because Python is free. It's easy to use. The design philosophy emphasizes the readability of the code. My 15-year-old son has got into Python programming. The syntax of Python requires fewer lines of code than other languages like C and C++. It's powerful, it's scalable, and it's portable.
And to make it fun, because as we all know, we all should know that's how we learn best, we decided to build some exercises around programming a USB robotic arm, which costs under £35 in the UK. Now it was Phil who first told me about the robotic arm, having read about it in the Magpie magazine, a Raspberry Pi focused publication. Slide 6. Okay, I'm a tester. Why should I learn to code? Fortunately, we didn't have to, in the workshop, we didn't have too many I'm a tester, get me out of here moments. So why should you learn to code? Well, first off, you don't have to learn to code if you're a tester. You can work successfully as a tester without finding out the first thing about programming. However, the world continues to change and move forward with the advent of agile approaches which encourage an understanding of code, and more recently the IoT, Internet of Things revolution, where supposedly even your refrigerator will be ordering your shopping for you, and rapid prototyping approaches that the maker community are using. For example, check out Kickstarter for a review of some of the amazing products that are being rapid prototyped. All you need to do really is hook up a 3D printer and you're away. I think what's happening here is that the paradigm that hardware is always the last thing to change has been completely reversed by this maker rapid prototyping revolution, and we're beginning to see hardware change at a faster rate than software.
Saying that though, we don't think that as a tester you have to sit there all day writing code. However, being able to read code gives you several advantages. An understanding of how to write code will give you some insights into the kind of errors that programmers make. And you'll also get a feel for where errors are likely, given an understanding of how the code was constructed. This will make you a better tester now and set you up with useful skills for the future. There is an argument that programmers should learn to test, and that will make them better programmers, but that's a discussion that's not relevant for today.
Okay, slide 7. So what do I get if I can code? A bit better as a tester, but so much more. When you sit there thinking, if only I could, well, now you can. No longer do you have to wait for some programmer to come through and reluctantly code some demeaning test utility. You can do it yourself, and they're not demeaning really. You can write some code to work as control scripts, data generation programs, data fuzzing, results checking. You could automate a boring manual process. Any utility you can think of, really, that you need or that you want. The possibilities are endless. All you need is a light bulb, and the light bulb is for the ideas.
In my role as a tester, I test lots of web-based applications with different URLs, port numbers, etc. Having these in sort of bookmarks or the favorites in the drop-down of the browser can be time-consuming to find the right link, to find the right web page, especially if you work like me in an organization where when you open your browser starts up, you get a company home intranet page which is extremely slow to load. So I've written myself a very simple HTML script that lists all the web applications that I test, their various different environments and any particular odd sort of login process. I've got this saved as a file on my desktop, and all I do now is when I want to test or start testing one of these applications is just open this file from my desktop. It goes straight into the list of sites I need, and I just click on that site. So it takes minutes off what I do waiting for the home page intranet to load. A very just simple, useful HTML script.
And a good investment in your time then. And as a former programmer, I was amazed that testers just couldn't code their own utilities. I could, I did, and I still do. Okay, let's have a few disclaimers, because until now it all sounds wonderful. This is a webinar. It isn't a highly interactive workshop, and there isn't a real-time two-way discussion. Phil and I are not teachers. In the workshops, we just show the delegates how to do things. We don't teach them. And then the hope is that through repetition, eventually will come understanding. For those who are inspired to have a go, all of the code examples, a video and a 30-page paper are freely available for download at my personal website. So that's me, Graham, at www.badgescroft.com. That link will come up again at the end. And you've got some illustrations there on the right-hand side of the screen of blog entry that I've written and numerous downloads that are available. So there are a number of downloads and a Pearl-Tree's collection of web links, of the web links we're talking about today as well.
The paper and the slides will also be shared after this webinar by EuroSTAR as part of their ebook series. So if you get lost following us, you know where to go and look and find the answers. I believe there will be a password to download the ebook given after the presentation today.
That's correct.
Sorry, Dara. You were about to say?
Sorry for just jumping in there. Just Phil had mentioned there that we'll be sharing the ebook at the end of the webinar. So I just wanted to clarify with all of our attendees that I will have a password for you at the end of the webinar where you can download an ebook on this topic. So sorry for cutting in on you guys. I'll
no worries.
Thank you.
And you'll be emailing the links out with all the rest of the links from the week's material as well.
That is correct, yes.
Okay, thank you. All right, so setup. I don't know whether I've just made this up or whether someone really did say nothing great was ever achieved without a few software installs. For the workshop, we definitely needed to load 2 pieces of software on people's machines. The first was Python, which is amazingly already pre-installed on Linux and Mac computers, the latest operating system, Mac operating systems anyway, but however it isn't on Windows. As well as installing Python on Windows for the attendees at the workshop, we also had to set the path variable. So if you've ever set the path variable in Windows, you know it's no mean feat, and in every version of Windows that's ever been, you have to do it in a different way. And unfortunately, in the workshops, we were running on a Linux machine, so we couldn't really show people how to do that. We got there though. And secondly, we installed Genie. You can see the little teapot icon there, so it's like a genie in the bottle. Genie is an IDE or an integrated development environment.
You could write Python code in a text editor as a flat text file, but by using an IDE, this brings with it lots of advantages. These include syntax checking, tools to build the code, a debugger, highlighting contextual actions and autocomplete of commands, and it's very configurable. In case of Genie, it's relatively fast, it's free, and it's lightweight. It works on Linux, Mac, and Windows computers, and it covers not just the Python language, it also manages other programming languages as well.
We use Python 2 in the workshops, but Python 3 is now the preferred option. The only difference is the print statement syntax. Now this is a real bugbear in the world of Python because print quotes hello world end quotes has now become print open bracket or left parenthesis quotes hello world end quotes right parenthesis, and has been made to look like every other function in Python. It's the same thing, but if you aren't expecting it in Python 3, it can take you 20-30 minutes to find it on the internet.
Yep. In the workshops, we successfully ran the exercises on Linux, Mac, Windows, and as I mentioned earlier, an Android machine. So if you ever needed proof of Python's compatibility or portability, there it is. It's on multiple different platforms and machines there. I think we were going to go for another poll now. So this is the second poll, please, Dara.
Okay, I've just launched the second poll here. We'll give you a few moments to take part.
Yeah, we've mentioned the Raspberry Pi in the webinar so far. So do you have a Raspberry Pi computer, and what are you using it for?
We have over 70% of the attendees here taking part in the poll so far. We're just going to keep it running for a little while longer. But from what I can see so far, the results seem pretty conclusive. But just leave it run for another 10 seconds. If you haven't cast your vote there, please do so now.
And if you could read out the results at the end, please, Phil, because unfortunately on my presenter view of the slides, I don't get to see the poll.
Okay.
Okay, I'm just going to close the poll here now. And Phil will go through the results with you.
Okay, so do you have a Raspberry Pi computer? 88% of people said no.
Gosh.
6% yes, but don't really use it. 5% yes and just run the software on it. And only 2% have used the Raspberry Pi connected to devices via the general purpose input-output pins. So during our workshop with the robot arm, we actually use the USB interface, but we have got devices connected to GPIO if we had the time to go into those.
Yeah, so
okay.
I was just going to say, I think that's brilliant that, you know, some people have been doing this kind of programming on a Raspberry Pi. For the 88% of people who don't have one or probably haven't even heard of it, don't worry, you don't need one to do this. You can do all of this on a Windows PC or a Mac PC if you want to. Okay, slide 10. So now we're going to quickly take you through the 3 workshop exercises. These are the 3 simple steps. So the first step being sequence. And bear in mind, this isn't an interactive workshop. So our aim here is just to explain what we did in the workshops and show you that it isn't that difficult to get going in Python. Our first exercise is to write a program that inputs 2 numbers and multiplies them together. Even though this is a simple program, it's our first program, so there's a lot to do. Everything is new, and that it's change, and that makes us feel uncomfortable. But by the end of the workshop, anyway, it did seem like second nature. Firstly, we looked at the shebang, which is a crazy name. It's a special type of comment which sets the environment. That's on row 1 of the code that you can see on the right. This is the real code that we used in the exercise. In the exercise, you would type it in line by line and explain statements as we went and build up to the completed program. Comments, it's always important for code to be self-documenting and explanatory and easily maintainable. It might not be you fixing or amending the code. That's rows 2 to 13 onwards, anything with a line that starts with a hash. A print statement, probably the most commonly known command to non-programmers, and we've got those on rows 15, 23, 28 and 24. We've got an input variable. We input some data on rows 21 and 27, and we do some string handling as well. Once the code's been written, we move on to explain the process of compilation, where the IDE, the Integrated Development Environment, Genie, checks whether the code is valid as a process of compilation. It looks syntactically, and then it builds an object version. If the code is invalid, the compile will fail and give us some error messages. Genie's fairly lightweight, so its error messages are quite basic. More feature-rich compilers can tell you exactly what you've done wrong, and more feature-rich IDEs might actually stop you making the mistakes in the first place. And finally, because I believe all programs must run, we then execute the code. In the exercise, so as I said, we step through the code showing each statement, explaining what it does, write a bit of code and execute it. So even with our first program, what we actually build up doing is compiling it and executing it a number of times, gaining confidence all the time. Just a statement here, because some of you might know about Python. Python is generally accepted to be an interpreted language. This means that a Python file or Python program is executed one line at a time, and at runtime the code is evaluated or interpreted. Python can also be compiled for some small performance gains on larger programs. However, the process of compilation is a very useful check, even if we're only executing files through the interpreter. And please don't worry if you don't understand any of that yet.
So the code you can see on the right there is the actual code as it's shown in the Genie ID window. We've not made any color changes to highlight anything. That's the IDE itself being helpful, showing you what you've got there. Red for comments, so that's the hash at the start, shows all the comment lines, and they're highlighted in red. We've got the blue there, such as print, that's for sort of a statement. Functions are shown in the dark red color there, such as input, and variables are shown in black. We're not covering variables in this presentation because that could go on for hours just in itself, so we're just trying to give you a sort of a taster here. Having these colors shows the main elements of the code that you're writing. Essentially what this one does, it prints out hello world. Every first program needs to do that, and then it asks for two numbers to be inputted, prints out the numbers to confirm the input, then multiplies the two numbers together and prints out the answers. In the exercises, we also had suggestions to enhance them once you felt comfortable with the code. And in the workshop, we had successfully run the program. We moved on to testing it and finding out the errors in the code.
Okay, so that's a very brief view of writing a program. Then we have to run it. So slide 11 is the output from running the program. On the right of the screen you can see a terminal window in which the Python program is run and the output it generates. First the program prints out hello world, then asks for number 1, which it then prints out and follows with the number 2. Finally it displays the result of the calculation correctly, we hope.
The output doesn't look particularly amazing unless that is you've actually coded it yourselves. There's a lot to cover in the first program, and already it's an achievement to get this far. You've gone beyond the simple print hello world stage and started to write code which will build into a more complex program. Below the program there's a flowchart, a very simple visualization of what the program is doing. Graham and myself both like drawing flowcharts. They do help with understanding logic and especially useful with more complex programs.
Thanks, Phil. Okay, slide 12, and I'll try not to read your notes next time. Slide 12, so let's look at exercise 2, which is iteration. So this is the second of the 3 simple steps. Some would say dangerous steps, actually a very powerful statement. we're going to look at iteration, so doing something multiple times. We're going to write a program that counts down to 0 from an input number. And here, in this program that you can see on the right, it's actually shorter than the first program. That doesn't mean it's doing less. We see a more robust form of input called raw input. In the workshop, we had time to explore the use of input in exercise 1. Input itself returns whatever's entered. So if a string is entered, then a string is returned. If a number is entered, then a number is returned. And in the first exercise, unless a number was entered, the program failed. Not very robust. Raw input always returns a string, so it's a known quality. That's on row 17. You'll see that. Because we have a string and we want to use the number value, we now have to convert that string to a number, and that's what the int function does for us in row 18. Loops in Python are identified by indentation, so anything that is indented belongs to the line above it that isn't indented. So rows 23 and 24 belong to row 22, and you can see in the IDE a little outline is drawn on the side of the screen to help you understand there's some indented code. And in our case, this is a while loop which will perform the indented code until the while condition is true. So rows 23 and 24 will be repeated whilst the condition on row 22 is correct or valid. We must remember in the loop, because we're counting down to 0 from an input number, to decrement or the counter, so subtract 1. Otherwise the loop will never end. So that's row 24. Essentially what our program does is enter a loop start point. This is converted to a number. We print out that number just so that we know our program is working correctly. Then the program loops around printing out the number, then decrements the counter until it reaches 0, where it prints finished.
A loop is a very powerful construct. A lot of work can be performed for only a small amount of code written. However, get it wrong and the program can continue running forever, or more likely until it crashes. If you think your loop is out of control, loop in, then you can type Control-C to terminate the process. This is sometimes why you see print statements in loops, mostly so that the programmers know that all is working well as the loop progresses.
Right, okay, so let's have a look at the output from exercise 2. It's a very simple program, but it's also very powerful. If you look at the output, you can see that we formatted it to leave a few more blank lines to ease readability.
Right, the more keen-eyed of you amongst the attendees there may have noticed an issue with the output. Going back to the requirements, we were asked to write a program that counted down to 0. There is a bug in the code, a deliberate one we admit. We used a greater than comparator, but should have used a greater than or an equal to comparator. By using the wrong one, the program has exited out of the loop one step too early, and the final 0 is not printed. This sort of error is something that testers you should be looking for, although now as a programmer you're within your rights to say that this is a feature. In the workshop we also asked delegates to amend their program to count up to a number. That requires using the Python comparator equals. Right.
Okay, thank you, Phil. So moving on to decisions, exercise 3 decisions. Already our programs are becoming longer and more powerful. In the workshops at this point, after only an hour or so, the delegates were quite comfortable with the IDE compiling and executing programs.
Yep. Exercise 3 compares two inputted numbers and reports which is higher. Here we are using conditional statements, if, elif, and else. Elif is Python language for else if, and it helps to cut down on unnecessary indentation, making the code more readable. The program begins by printing a message of its purpose, at row 14 there. Then it asks for two input numbers, again using raw input and converting the string to an integer, rows 18 and 19. The decisions firstly compare whether number 1 is larger than number 2, and if so, prints that result, rows 26 and 27. Else, it asks whether number 1 is less than number 2 and prints that result, rows 28 and 29. Otherwise, or else, the only logical answer that we're left with is that the numbers are equal. So we print that result, rows 30 and 31. We've used \n for a new line and spaces for the indentations to make the output more readable. For the result print statements on row 27, 29 and 31, we've concatenated together text and variables. Python will only concatenate the same type of variable, and because we want to display some text, i.e. a string in this case, we've used the original input strings and added these as the variables. We could also display the integers, but we would have to then convert them back to a string using the string function.
Right, so let's have a look at the output. On execution of the program, you can see here immediately how the output's more readable. We've used blank lines and indentation to help with that. As testers, think how many test cases you would need to test the logic in this program. It's an interesting challenge, one we set in the workshop. In the workshop, we then asked the delegates, excuse me, to amend their working programs to check whether the numbers are equal first, using the Python comparator equals. And there's an important point to note here. We've included flowcharts to illustrate the simple logic of these programs, but already we've moved away from sequential code to loops, and you might find that you need tools to help you understand the logical flow of your programs when they become longer or more complex. So armed with an understanding of sequence, iteration and decisions, you'll already be able to write quite complex programs even with a minimal understanding of Python. Okay.
Yes, so with that understanding, in the workshops we challenged the delegates to write a program to control a robot arm. So we set it up so it was holding an erasure in its jaws, and we gave some snippets of code for the USB control characters, and by following a flowchart and using sequence, iteration and decision to complete the challenge, we got the delegates to write their own programs to control the arm. It's much easier to control the robot arm on the Raspberry Pi rather than via a PC or Mac. So the delegates wrote the code on their machines, we transferred it to the Pi connected to the robot arm, and there was a finger poised over the off button on the robot arm just in case that the code wasn't quite correct. We had some near misses, but at least one tester in each workshop successfully coded a program to complete the challenge.
It was Phil who first alerted me to the robot arm. I couldn't believe that you could buy a USB robot arm for less than £30 It is self-assembly though, so there is a little work to do, and don't use super glue to connect it together as one of my friends did. But using something like a robot arm, this is where you begin to feel like an embedded systems programmer without a test environment. Every run of your program happens in live, so be prepared to switch the arm off before it goes out of control, which did happen a few times.
It did.
Right. Okay, so we finished the code now. So, and this is amazing the number of people who've stuck through us with that. But before you get carried away, it's easy to get started in Python, but Python and all programming languages have great complexity, subtlety, and nuance. As the diagram on the right-hand side of the page shows, I believe 80% or more of all code written is there to handle errors and exceptions. The examples that we've shown you here are not bulletproof. They are not production ready code, as was very easily demonstrated in the workshop. They are there to show people how easy it is to get going and then learn some of the essentials.
Python itself is a rich and powerful language that we haven't even begun to scratch the surface of with these exercises. There are a huge number of built-in libraries that quickly expand the capability of your code, and you can download numerous routines that are freely available to expand your own programs. There's no need to go reinventing the wheel each time for these programs you want to write with Python.
What we wanted to do, Phil and I, was take the delegates beyond print hello world and actually get people started. We wanted to encourage and inspire them. We want to encourage you to want to do more. Definitely do the exercises, and if you do the exercises, do some more programming afterwards to reinforce the learning. Anything you do learn, you should reinforce that learning as soon as you can. So we encouraged everyone, after they'd done the workshop, we left the exercise, the completed working exercise files on their laptops so that they could take them away and they could run them again and they could see what they had done and they could build on that.
Okay, so here's some references that you probably find useful for your own programming journey. Python.org, everything to do with Python. The Python Beginner's Guide, a link to help you start to learn about Python. There are also online Python tutorials. A very good website is codecademy.com. They do other programming languages as well, so don't restrict yourselves to Python. There's a link to the Genie IDE, the free IDE, integrated development environment that we use for our exercises. And there's also the Raspberry Pi Foundation website. So if you've intrigued by the $35 quad-core Linux computer, go and have a look at that website. Lots of exercises and makers building things there with the Raspberry Pi.
And if you visit my website, which is www.badgerscroft.com, you'll find a blog entry with complete links to this presentation where you can download the slides, exercise videos. No, sorry, I meant exercises, videos, and there's the paper, which is also available as a PDF as well from EuroSTAR. And the paper describes the exercises and how to get them up and running in atomic details. So we have skimmed across those exercises today, but the paper takes you right through into the very detail of what's happening with each line of code and each statement. And if you get stuck, and try a Google, Bing or Wikipedia search, and actually quite a lot of people produce YouTube tutorials which are actually excellent for doing so. Just a word of warning though, I'm sure you know, not everything that people post online is helpful though, so if you are unsure, check a couple of references first. And to summarize, so the picture on the right of the screen is one of the latest views of Pluto sent back by New Horizons. Amazingly, it shows the layers in the haze of Pluto's atmosphere. We're not kidding ourselves here today in thinking that these simple exercises will give you that level of understanding of programming. If anything, hopefully it's becoming a little less blurry. But hopefully we have given you a bit of insight into programming, and the testers should code debate.
Yep, we hope that we've inspired you to take your own Python programming journey. Let today already be that first step. For your next steps, download the paper from Graham's website or the EuroSTAR ebook, work through the exercises, go online and work through some of the Python tutorials. And find a project to start programming, be that a Raspberry Pi or utility application back at work. But definitely capitalize on the investment of this time that you've made today and build yourself a personal development plan to start programming. Okay, I think we've got the last poll now. Dara, please.
Okay, just going to launch the last poll here, and you should see it now. It's asking you, after this webinar, are you A, more likely to do some programming, B, you're unmoved, or C, less likely to do some programming, it looks too hard? So tick on the box that applies to you. And we've up near 70% of our attendees have ticked one of the boxes. We'll let it run for another 10, 15 seconds. Okay, I think that's everyone there who's going to take part in this poll. So let me just close it here and share the results with you.
Okay, so 77% of people are more likely to do some programming, 21% are unmoved, and 1% are less likely to do some programming because it looks too hard. So thank you to those 77% of people more likely to do some programming after our webinar today.
Well, it's excellent. Very worthwhile. Thank you.
Okay, thank you.
And that's it. So thanks for listening.
Thank
Are we
you,
back
Graham.
on the slides?
Yes, we're back here on your final slide here.
Well, all I'd like to say is thank you to everyone for listening. It might have been hard work in the middle, but 77% of you think it's been worthwhile, so brilliant. Thank you for that. My website's listed down there on the page so that you can check that out if you want.
Yep, and thanks for listening to me as well.
Okay, before we go through some of your questions, I'm just going to share with you the link now to the resource page where you can download Graham and Phil's ebook. And you'll see it there in your chat box. And as an attendee at the webinar, you'll get to download this before the rest of our community. So the password to download this ebook is PFT 2015, so Programming for Testers 2015. And we hope you enjoyed the ebook. Now, this Friday is our super early bird deadline. Just want to remind you that if you book your place before September 18th, you can get up to €200 off your conference ticket. And you can make even greater savings if you register a group booking, where you get one ticket free for every 4 delegates you register as a group. We also have a new conference starting on the Friday after EuroSTAR on November 6th. It's called Mobile Deep Dive. Tickets for this is €850, and you can add it to your EuroSTAR conference ticket for just €425. And all the information you need on both programs, as well as the pricing and discounts, is on the EuroSTAR website. I mentioned at the start of this webinar that we're running a competition all week, and today's number is 85. So just take note of that, and I'll be sharing 3 more numbers with you over the next 3 days. So just take note of those, and I'll also share with you the email address to email them on Friday after the Internet of Things webinar. Tomorrow's webinar is on how is testing different in a DevOps Agile team, perspective from the team, and that's with Rob Lambert and his team at New Voice Media. And you can register for this webinar as well as our 2 other webinars on Test Huddle. So you'll click on the slider there, it'll bring you right through to the Way We Work series. And now let's take a look at some of the questions that you guys have sent through. So if you bear with me 1 second here now. The first question I have here says, at the company where we work on all types of projects from SharePoint to net-based projects. Is learning programming applicable to all types of projects?
Phil, do
I'll
you want
jump
to
in
go?
first for this
Yeah.
one. Yeah. Yes, I think learning programming is relevant to all types of projects. Having that understanding of how the code is constructed will help you pinpoint where defects are likely to occur. And even if you're looking at something like SharePoint, it's a third-party application. It's not something that you test. You don't generally test some software that you buy that's like Microsoft Office, but having that understanding of where things could go wrong in a particular application, which you only really get from the code, will help you as a tester.
The next question I have here says, for any programming languages, is it important to learn the syntax of that language?
I'll have a go at that one, Dara. I think the ultimate answer is yes, because it makes you a better programmer. But to start with, no. You will know a few commands and get to learn a few commands. There are hundreds, if not thousands, of keywords in some of the languages. This is where we use an IDE, an integrated development environment, because had we actually demonstrated using Genie, as you type in the command, Genie, the IDE, fills in the rest of the command line for you and shows you a template and what parameters you need to fill in. So IDEs are very helpful, although you have a rough idea of what you require to what the syntax is for the language. The IDE can help you filling those in, but you definitely need to understand what the commands do. As a programmer, this is quite a few years ago, I would, whenever I learned a new language, I would always read through the commands of the language to help me understand what it does. But I don't think you should start by looking through all of the commands of a language.
The next question I see here is, what do you think of PyCharm as Python IDE? Have you tried it?
This
is Phil. I haven't tried it myself.
And I haven't either. There are lots. I suppose Graham here, I use Genie because I read a blog post about it. It works. There are quite a lot of tools to use. The freest, cheapest, lightweight, easiest to use one, I think, is the ones I've used. So if it works for you, fine.
So say if it's down to personal preference sometimes. So yep, most I've not heard of any bad ones.
The next question I have here says, if I learn Python, how is it integrated to a software product that we test?
It doesn't have to be integrated to the software products you can test. It could be used just for creating test data, for example. So I work on a CRM system where we type in client names. We can't use real client names, so we've got a small routine that generates unreal names. That's not real word. So it just generates made-up names, synthetic names, and that's just a small utility that's not part of the main program, but it's helping us with data that we can feed into that main program.
Yeah, I'd like to add to that, Phil, and say that just because you learn Python, it may not be the language of the system that you're working on, but the first programming language you learn will help you learn the next programming language. And people just talk about just another language, yet another language. Programming languages come along very, very frequently, very regularly. Developers are always changing the languages they're using. Python has been around for a while now and does have some longevity.
Next question I see here.
Shall we, shall we take this one and one more?
Sure. Okay, so the second last question we're going to take here today, an interesting one here. It says, doesn't learning programming make us lose a bit of our testing way of thinking?
Very interesting question, but I think if you've got the right tester mentality, the what happens if I do this, learning the programming can only help you sort of hone that ability. So you know that weaknesses in code, like we showed with the greater than or greater than or equals to in the exercises, as a tester you can think, oh, there's an age boundary here, or there's a number boundary, there's bound to be some errors around here, so you can go into that and focus in on it.
Yeah, I don't think it detracts from. That's like saying if I learn to do anything else, will that detract from my testing skills and abilities? No, I don't think so. Your ability to question and understand at that level will add value to being a programmer. I don't think programming will detract. It's my experience. I started testing after programming, so I can't tell you what it's like the other way around. But I haven't lost any programming skills because I'm now a tester, and I don't think it works the other way around either.
Okay, we're almost out of time, so this is the last question we're going to take today, and apologies for those of you whose questions we didn't get a chance to get through. They were just randomly selected here, and the final question I have is, in the emerging world of technologies, today it's Python, tomorrow it can be something else. What can be done to keep yourself up with the change?
Well, the first one I'll say is you're doing it today by attending a webinar on technology. So any webinars, conferences, tester meetup sessions, go out there and meet people, find out what other people are doing, and hear what's going down on the street, as it were.
Yeah, and I'd add that if the concern is that why should I learn Python because it's going to be superseded tomorrow, Python's been around a long time actually, and gets better and better. So I don't think there's a problem there, and I don't think any investment in time with Python will be wasted in transferring to another language at a later point in time.
Thank you both very much for today's webinar. It was really interesting, and we had lots of people there, and the feedback has been fantastic, and your ebook as well is going to be just as popular. And I've shared with you guys as well the link to the Way We Work series if you want to register for the other 2 webinars we have this week. Thank you again to Graham and to Phil.
Thanks, Dara.
The webinar is now over, and you can look at a recording of this webinar over on Test Huddle very shortly. Thank you all, and goodbye.
Thank you. Bye.
Thank you. Bye-bye.